Hi folks, today we're looking at going beyond the first revolution when we deal with trigonometric equations. As always, there are downloadable notes in the video description below, as well as a worksheet for when you're done. So up until now we've found solutions to things like sine x equals a half in the first revolution. But let's just take kind of a backtrack here for a second. Let's suppose I had an angle like this. Let's say I had 70 degrees. In standard position, there are actually an infinite number of angles that end up at 70 degrees. So there's 70 degrees, or there's also a full revolution plus 70 degrees, which would be 430 degrees. We could go another revolution on top of that, so we could have 2 revolutions and 70 degrees, which would really be just like adding 360 onto your 430. So that would give you, let's see, 790. That's another angle that should end at the same place. Alternately, we could have gone backwards, and that would have been negative 290. All of these angles, 70, 430, 790, negative 290, and an infinite number of other ones end up at the same place. And those are called coterminal angles. So if we take that idea with our trigonometric equations, it turns out that sine x has a few more solutions than we might originally have thought. So I'll go through the process really fast here. Theta ref would be, we'll do this in degrees, 30 degrees. It would be in quadrants 2 and 3. Okay, and so that would look like this. 30 and 30. And we'd know what to call those angles. We call the first one 30 degrees. And the second one would have been 180 minus 30, or 150. Those are our 2 solutions in the first positive revolution of angles in standard position. But there are a whole lot of other solutions as well. There's this one, which would be 360 plus 30, or 390. We could have gone 2 revolutions, so let's go around again. That's 720 plus 30, or 750. If I had have gone in the opposite direction, well, that would be negative 330. Okay, and then there'd be infinitely many more revolutions you could make. So there are a whole bunch of solutions here. Same thing could have happened if we had dealt with that 150 angle. Okay, that's 150 to here, but keep going and you'd have 150 plus 360, or 510. You could add another 360 on, and that would get us to 870. So every time you add on 360, you're adding on a revolution. We could have gone backward instead. That would be negative 210. There are a whole bunch of solutions. Now, what do the solutions look like? The solutions are all the angles, coterminal, with 30 degrees and 150 degrees. And in the next video, we'll look at how we can write out that infinite set of all possible angles. But in this one, we'll just look for specific solutions that are beyond the first revolution, but in a specific domain. And it's really not that hard to do. If we want to find solutions beyond the first revolution, we simply add or subtract multiples of 2 pi, or 360 degrees, remember those are the same thing, to the initial solution, or the solution in the first revolution. Let's give it a go. So here we're going to solve the equation cos x equals negative root 3 over 2. And here is our domain. Negative 360. So we'd think of that as 1 revolution backward to 720, which would be 2 full revolutions forward. The domain could be whatever, but in this question, it happens to be from 1 revolution backwards to 2 revolutions forward. Most of our process stays the exact same. So as always, we're going to look for theta ref, which means we're going to figure out where cosine is root 3 over 2. That happens here, and since there are degree signs right here, I know that I'm dealing in degrees. So this will be 30 degrees. ASTC. Okay, this is somewhere where cosine is negative. So cosine's negative over here and over here. Let's actually sketch those angles. So that would be 30 degrees and 30 degrees. Now let's find those in standard position. And I'm just going to look for my first one in the first revolution. So that's 150 degrees. And if I were to do it for the other angle, that would be 180 plus 30, or 210 degrees. Now we have to ask ourselves, are there more? So that's in the first revolution. Let me go and get that first one, the 150. And in the second revolution, it would come up at 360 plus another 150, or 510. So really, we just add 360 on. And that gets us our 510. If instead I had have looked at going to that one, but backwards, well, it would look like this, which would have been negative 210. Okay? And we could have thought of that as subtracting 360. So if we do it with the diagram, pretty quickly it looks pretty crowded in there. But if we think of it in terms of just adding 360s on, well, then it's not so bad. Okay, the next one, if I do it with the diagram, then I could go that purple one. I'll put an extra revolution on it. That's 360 plus 210. Okay, what does that give us? Plus 360, 570 degrees. If instead I'd wanted to go backward, I'm running out of colors here. I'll do a broken line. If I went backward to that purple one, that would have been negative 150. Okay. Let's fill that in. Negative 150 degrees. Or it probably would have been easier for us just to think, subtract 360 from that 210. Now those are all the solutions. You might say, well, why can't I just go further? Add another 360 on. Well, if I add 360 on, I'll be at 870. And this will give me 930. Look at that original domain. It only went to 720. So these are no good. That's too far. Similarly, if we kept going to the left, then we'd be at less than negative 360. So we'd be outside of the domain. The last thing we have to do is just elegantly write our solution. And you can write them in order. It's the set of negative 210, negative 150, positive 150, positive 210, positive 510, and positive 570. Between the first revolution backwards and the second revolution forward, those are all the angles that give you a cosine of negative root 3 over 2. And you could try them in your calculator in degree mode, and they would give you a cosine of negative 0.866 or negative root 3 over 2. Let's try one in radians. So this is actually the exact same question. It's going from negative 2 pi, which is 1 revolution, backward, to 4 pi, which would be 2 revolutions forward. Now again, We think of this because pi is 180 degrees. So we're going to find our basic answers, and we're going to then look at how we can expand them or extend them to deal with the domain that we have. Okay, so theta ref, cosine is root 3 over 2 at pi over 6. We're going to get the exact same answer, just in radians on this. Cosine's negative in quadrants 2 and 3. Let's go and sketch them. And the sketch is going to look the exact same, just with pi over 6. Okay, and now let's find those angles. So the first one I'd think of as pi minus pi over 6. Or 6 pi over 6 minus pi over 6. Hey, that gives us 5 pi over 6. The second one I would think of as pi plus pi over 6. Or 7 pi over 6. Now we can draw the revolutions on, but really we know what that means is that we're adding 360 degrees or 2 pi to find our next coterminal angle. Now that looks kind of unpleasant, 5 pi over 6 plus 2 pi. In order for us to add fractions, we need to have a common denominator. So let's rewrite 2 pi as what it would be over 6. 2 pi, or 2, is 12 over 6, so this is 12 pi over 6. Add them up, gets us 17 pi over 6. Okay, that would be the solution that's in the second revolution. If I wanted to go to the solution that is backwards, if we're dealing with angles in standard position, then we just subtract 2 pi. And again, you want to think of that as 12 pi over 6. So we have a common denominator. Okay, so that's easy. 5 minus 12 is negative 7 pi over 6. I wouldn't go any further than that because that would bring me beyond the first revolution backward. And I wouldn't go any further to the right because that would take me more than 2 revolutions forward. And if you did it, you'd just see that your numbers are too big. They don't fit in the domain. Same thing. We're going to find the coterminal angles for this one. So 12 pi over 6 is what we're adding, which is 2 pi. That's going to give us 19 pi over 6. If I want to go in the opposite direction, I subtract 2 pi, which is 12 pi over 6, and I'd get negative 5 pi over 6. Okay, we can write our answers out nicely now. X is the set of. And I'll put them in order. Negative 7 pi over 6, negative 5 pi over 6, 5 pi over 6, 7 pi over 6, 17 pi over 6, and 19 pi over 6. These are all the angles that give us that cosine that we want. Okay, so there's the solution set. If you check those all out in degrees, they would be the exact same answers that we found in example 1, because it's the same question. It's just given to us in degrees in example 1 and in radians in example 2. Let's do one more. Sine of negative root 2 over 2. So, as per usual, we're going to find theta ref. Sine is root 2 over 2 at 45 degrees, or, it looks like we're working in radians here, so pi over 4. Now, the domain on this one is a half revolution backward to a half revolution forward. ASTC, we know that sine is negative in quadrants 3 and 4. So let me draw this. Pi over 4 and pi over 4. If I were to answer this normally, I'd probably think, well, this is pi plus pi over 4. Makes it 5 pi over 4. And I would probably think this is 2 pi minus pi over 4, or 7 pi over 4. But if you look at the domain, those are both outside the specified domain. We need to find some angles that satisfy this equation, so they're coterminal with those ones that are given, but also lie in that domain between negative pi and positive pi. Obviously, adding 2 pi onto either of these solutions is going to get us a number that's too big. But if we try going backwards and subtracting 2 pi, we might be in luck. So again, you're subtracting off in fractions, you need a common denominator. So just think of this instead of 2 pi as 8 pi over 4. That gives us negative 3 pi over 4. Is that within the domain? You betcha. That's a great solution. Same thing over here. If we have 7 pi over 4 and we want to subtract 2 pi, well, I really think of that as 8 pi over 4. Okay, and what will that give us? It'll give us negative 1 pi over 4. Now, those initial ones, they were no good. They were outside the domain. But these ones over here, these are great. They're within the domain. So let's write them down as our solutions. X is the set of negative 3 pi over 4 rather, and negative pi over 4. Now you might have got to those solutions a whole lot easier by just thinking, oh, this right here, that is negative pi over 4. And this one right here, that's negative 3 pi over 4. So if you can see it from the diagram, by all means, just do it from there. Or we can do it algebraically and then make sure that we're fitting in the domain. Okay? So that's what we're adding in at this point, is the fact that there are all these coterminal solutions, but we need to make sure that we're in the appropriate domain. Next video, we'll look at the general solution, so all the possible solutions. See you next time.